Hope everybody is ready for your last day here at Discover. And appreciate the opportunity to come share with you a little bit about what we're going to do in the new HP Incorporated post-split. So my role is Chief Technology Officer for printing and personal systems currently, and then post-split here effective really August 1 we'll be operating that way. I'll be the CTO for HP and will be the director of HP Labs. And so what I wanted to do was share with you today a little bit about our vision, where we intend to take the company, and really looking out in the longer range here in the 5 to 10 year time frame of how we look at the opportunity before us. And the best place to start with that is always what's going on from an industry standpoint. And here it's very simple. I think we're at a very interesting inflection point from a technology standpoint, and that is the blurring between our physical reality and our digital reality. So what do we mean by that? I'll give you a few examples. So I picked 5 main areas. Each one of these in and of itself represents a giant market opportunity, but you'll get a sense of what blurring really means. So first is 3D transformation. We tend to look at this one as 3D printing, and we're all constantly amazed at what we can actually create from a digital representation of something. But very much an example where you took a digital printout, or excuse me, a digital print, something that would be a representation of an item that you could manipulate in digital space, and you can actually turn back around and print it out. And you can have a physical representation of it here. So you're actually blending what is the physical reality and a digital reality. And with 3D scanners today, you can actually take the physical item, and with a 3D scanner, with a hand scanner or others, you can actually scan the item in, you can manipulate, you can change it. Here again, blurring our physical and digital worlds. The second big one is in the area of immersive experiences. Now, some of these we see today in things like virtual reality, things like an Oculus headset. And if you look at the next versions of those, you can put those on and you actually become fully immersed in a complete different environment where you actually feel like you're there. There again, blurring that physical and digital realities. And then in hypermobility, today we know that as certainly the mobile devices we use today, the tablets, phablets, phones. But that quickly is going to move on body. And we're seeing pieces of that today in terms of the primitive wearables that we have available. But it's going to go way beyond that, where it actually ends up on the body and can do sensing of the body, acting on data on the body, turning it back into digital representations and things you can do about it. And we all know about Internet of Things. We tend to look at it as the items that we attach technology to, have them communicate back up with the internet, associate with a service, and it actually then able to control physical things in our environment. And it's everything from agriculture, where we can actually sense things in a field. We can tell where we're low in nitrates in particular areas. We can then compute that, turn back around, and then through drones or planes or tractors or other means, we can apply exactly the right amount of fertilizer in the right area. Here again, really blurring the physical and the digital. And finally, in the area of smart machines, where in smart machines, we're seeing the things of emergence of drones of all variety, and we're seeing these smart assistants, simple version here of a Roomba. But we've seen all versions of those come where they actually end up being physical assistants. One in Japan I saw recently that was quite interesting. It was a different interpretation of the Roomba, but it essentially spoke to you. It had a mood. It had a quality of he was either happy or sad. It would ask you questions. It had a camera on the front of it. And when it found interesting things, like the tennis ball your dog put under the couch, it would take a picture of it and send it back to you on your cell phone. Here again, blending that digital and physical reality. So it's this transformation, this trend that is going on that we intend to take advantage of, full advantage of, within the new HP. So how are we going to go about doing it? I want to share a little bit of that with you today. And it starts with a vision of how we intend to approach future opportunities. And we call that blended reality. Very simply, we take the physical things, the people, places, and things. We sense, we capture, 2D or 3D. We connect those back up. We then compute, analyze, communicate based on that, and we turn back around and we modify, change, communicate our environment on the back end. All of this together is a vision that we drive called blended reality. So I want to give you 3 specific areas that we're driving today and exactly how we're doing it. And I'm going to start with mobility. And you know, mobility is a simple one because we all know those glass slabs that we use today, those tablets, phablets, phones that all of us stare at on the average 137 times per day. Those are pervasive. But what we're watching now is we're watching that move from being some glass slab into an item on your body. Now, it started very simply with the Fitbit or the simple wearable, the ugly piece of plastic that was attached to your arm, or the bright, shiny little screen that was attached to your arm. But we think it's going to move in an entirely different direction. We don't think people will buy that in a sustainable fashion. We think people will focus first on fashion and want the technology to be a supplement of that. Last fall, we introduced a whole new approach, a different look about how you would do wearables, and it was all built on fashion. And we went out and we partnered with the 2014 Men's Fashion Designer of the Year, and we went and built a watch. And it was a watch first. People would frequently ask me, well, what does it do? And my answer was, it tells time. And that is the most important thing. It's a fashion statement. It's a statement about you, what you like, and who you are. The watch was introduced and it sold out. We did 2 versions, a base version and a higher end version. The higher end version sold out in 3 hours. So we're now taking all of the learnings from this and we're folding it back into a new set of products that will, here again, target the fashion industry, focus on fashion first, and technology as a supplement. But in the mobile space, we don't think it will stop here, and we intend to drive into new areas where the technology will actually come on body. And we've been experimenting with a new set of things in conjunction with a couple of our partners where you can actually take the technology itself and it embeds on your skin. In this case, it's a very simple NFC radio with a couple sensors, and those sensors can detect things like your temperature, humidity, amount of water, chemical composition, things like this. And they can be placed on various parts of the body. Now today we experiment with them in things like performance athletes who would use these in order to say when they need to take in fluids or they need to take in energy. But you can imagine using this in all sorts of medical environments as well, where you can monitor aspects of things, and eventually we'll get to the point where you can actually do things like monitor blood sugar and then turn around and be able to control an insulin pump. You're blending that physical and digital reality. And we think what we've seen today so far has mainly been in the consumer space, but we actually think some of the bigger opportunities are at work, where you take some of these things, where you take an actual object, so a wearable that you wear, you come into the work environment, it detects that it's you, it opens the door, you come in, it knows that it's you in front of your screen, it transfers a call. You walk down the hall, it knows you're coming, so they know you're running a few minutes late for the meeting. You come into that meeting, it's already loaded, your presentation. No more of this 5 to 10 minutes that gets spent at the beginning of every meeting to make sure it works with the projector. And then when you go home at night, it notifies your family, you're caught in traffic, you're 15 minutes late, and they know beforehand. Now, I don't know if it'll happen exactly like this, and it'll probably have all sorts of variants, but I can certainly guarantee that the wearables that we see today are going to become much more functional. They're going to come onto the body itself, and they're going to become a critical part of the enterprise. After all, what is the most popular wearable you have today? It is the badge, the item that gets you in to work. Making that smart and building intelligence into it is a direction we certainly intend to pursue. So the second big area when we think about blended reality is really in the area of Internet of Things. Now, this all started, obviously with the things themselves, where we actually built the computing into physical devices, started obviously as PCs themselves, but then those things quickly in the internet era went online, and we suddenly had PCs online with all sorts of services and websites. We had the tablets and phablets online, and we moved all of our shopping, our interaction, our social, our mobile online. Well, this was obviously just the beginning, because now we're putting objects online, and we now have the opportunity to connect all of them. Today, there's an estimated 16 billion objects that are connected to the internet. That is almost 3 for every 1 person in the world. And by the end of the decade, it's estimated to be 50 billion devices that are online, all part of internet services. But we actually think that is a minuscule drop in the bucket in comparison to what will happen over the next 10 years. Because we believe in a vision of internet of all things. Now, there's a few things we're doing in the short term. One of them actually starts in our printer business. And what people probably don't realize is that HP is one of the largest Internet of Things companies in the world. And it's all sitting in the printer itself. With tens of millions of printers deployed, many of those, in fact, all of them that ship today, are connected to the internet in a wired or wireless fashion. All of those have a back-end big data engine associated with them. So you, in an anonymous fashion, can tell everything about that printer. You knew the density of print, you knew the type of print, you knew the duty cycle. We know all aspects of that use. And it's allowed us to do things like give us subscription ink, so that you can tell somebody beforehand their ink cartridge is running out. You can deliver advertising to that person that says $5 off your next purchase, or in the case that we've deployed in the US and are expanding now further, you can actually have a subscription service. So it knows when your cartridge is running out, and it actually sends you the cartridge beforehand. And we've taken those printers and we built in an if this, then that engine. And if you don't know what that is, it's simply a rules engine. You can find simple applications of it on your phone or your tablet today that says when certain events occur, take these actions. And it can remember those actions and build up on it. And so that engine is now built into our printers themselves. So our printers are essentially IoT objects on the web. So that's already happened today. What you'll watch us do in the future is a couple things. One, drive it into the immersive home. And we've got a set of things we're starting now that will deal with personal home assistants. That'll work with how you can take things in the home, you can connect them together in a more seamless way, and you can actually provide a service to it. This is an area you'll watch us pursue here in the 2016 timeframe. And we'll move into the smart office. You heard a little bit about our view as it relates to wearables, but we actually think it goes beyond wearables. Most of the approaches that people are taking today in this space tend to focus on lighting or HVAC. And yes, I think some of those will actually happen, but there's some huge heavy lifting to make those happen. One, you have to actually replace the lights or the electricity going to the lights, or you have to change the HVAC itself. But we think there's much simpler ways to get at this using things that are already deployed in the enterprise: printers, personal systems. Through a series of sensors already connected to those devices, we can simulate all sorts of movement that goes on within the enterprise, what the density of people are, use of conference rooms, and we can create entire patterns within the enterprise itself. And we think this will create new hardware opportunities for us and obviously new service opportunities. But we don't think it stops here. In fact, we think it goes, as I said, to the Internet of all things. And we do mean all things. We mean the book, the physical book that was printed out in a customized fashion that would come from our digital printing capabilities, our publishing capabilities. And think of education, think of the student. And the student prints out, has a custom textbook just for him or her. And when they want to get more information about it, they simply point their phone at the book or point their tablet at the book, and they can have a complete lesson brought down to them that explains it in greater detail. Or think of the packaging, whether it's wine in this example or beer in this example, or it's all the other packaging that things come in that can have an internet address associated with it. Now, none of this has technology in it. It does not have compute in it. It does not have a radio in it. Our vision is that those objects actually are encoded with information that allow us to associate it with an internet service. And we've rolled that out today in what we call HP Link. I'll use another example here of, take for example, the grocery store, but a whole new interpretation of the grocery store. Imagine, and we actually did a deployment of this in South Korea, you walk through the train station. On the wall is a digital representation of the shelf at a grocery store. And it has all the objects that you could find at a grocery store. And you merely take your phone, walk down the aisle, and you take pictures of the items on the wall. They're purchased and they're delivered to your home. And eventually, that same technology will be built into the 3D parts that we print through our printing technology itself. So you can actually embed in physical objects copy protection and information about ownership and rights about the object itself. Truly the internet of all things. So it won't be limited to the 50 billion devices that'll be connected to the internet by the end of this decade. It could expand to the 50 trillion pages we print out every year. Truly will be transformational in IoT. So the last area I want to give you a little bit of a sneak peek into is what we call 3D transformation. And we think it's probably our biggest opportunity within HP itself. And very simply, it starts with transforming manufacturing itself. And if you rewind and you went back 150 years, pre-industrial revolution, if you wanted to make something, it was essentially handmade. And it was with the blacksmith where you sat with the blacksmith, you figured it out, and he did something very custom for you. But it was a one-off. You didn't have a way to do it in a massive way. Enter the Industrial Revolution, and we figured out ways to do blueprint design. So we could stage in things on the front end. We figured out how we would manufacture them in either a very labor or low-cost labor way, and eventually it moved to automation. And then we figured out how we would stage it in distribution centers and retail stores along the way. And that whole chain, end to end, essentially represented the Industrial Revolution. And when you took that chain and you sprinkled a little bit of marketing on top of it and can bundle it as one, you now essentially have represented what was the Industrial Revolution for the last 150 years. And it didn't matter whether you were doing Twinkies, tablets, or Toyotas, that same model applied. Now, when we moved into the internet era, things changed a bit. We accelerated that. We had computer-aided design. We had machines doing production. We'd order the object from the internet rather than from a store. But we did not change the model itself. It was still the same model of staging materials in, manufacturing, distribution. All of this is about to change. Now, it may take 10 years. It may take 20 years. But we believe there will be a fundamental transformation in manufacturing itself. And what enables that is front-end democratization of design, where you go from a much more immersive natural design to on-demand production. So what you can do is sit on your couch, you design something, you press a button, it prints out, totally disrupting the chain itself. So let's take a look at the front end and the back end of that. And on the front end, we have a product we introduced last year, which is our first footprints in the sand of where this is going. And it's called Sprout. You can see it outside the door here. And it takes a very different approach to the personal system. It integrates known technologies, but it does it in a much more natural and immersive way. So to give you an idea of what we mean by democratization of design and what's possible here, let's take a look at this video.
Surfing has a really deep tradition of shaping your own surfboard. And so I saw that need and created a place where anybody could come. Before Sprout, there wasn't really a clear way for people to come in and get their design in and out efficiently. It can be overwhelming. And with Sprout, it really allows the surfer to narrow down their design choices, whether it's a fabric texture that they want to see on the board or it's a 3D object. What are you thinking for your board?
Well, you know, I grabbed this burlap. I was
Okay.
thinking maybe we could use that in some way. What do you think?
Perfect. This camera button up here is gonna get it ready. Hit the blue icon.
Can we scan these directly right in?
Yes, just go ahead and arrange them on the screen there. All right, let's get that cleared. So now we got a bunch of elements we can play with.
Yeah, let's bring the burlap in as a base.
So you're just gonna swipe it right on in. So we'll go ahead and size it down so you can work with it.
Uh-huh.
And the first thing we wanna do is crop it. How's that look?
Great. Yeah, looks great. I was liking that green we were looking at earlier. Maybe?
Okay. Let's move this one down. Move the green over. So
Gotcha.
there it is.
Cool, I like that. Can I cut a shape out?
You can really create whatever shape you wanted for your inlet. All right, that looks real good. Let's go ahead and save this, and then we'll do the leave concept that you had, all right?
Cool.
Save as project. Cool, man. So here we are on the second concept. Just swipe down the leaves that you want to incorporate.
How about something like this and send the burlap behind it?
Yep, so just same thing, move the burlap over, and then push send to back. Perfect.
Awesome.
And you can resize the burlap if you want the full board in there.
I have one more idea that I was thinking about. You think we could try that?
Yeah.
Let's swipe it down.
Swipe it down. Oh, that's super cool.
Yeah.
You can crop that and then maybe shrink it down there. Then hit the blue check mark when you're ready.
Okay.
Perfect. All right, so here's our 3 choices.
I really love this one.
Okay, let's get to it. Sprout has really allowed us to grow our business because now we're able to offer so much more on the design and creative aspects. People kind of go crazy with ideas when you give them that opportunity to really start with a blank slate and just build whatever they want. It really engages the customer. They feel like they're taking more of a part in the design and the finished product at the end of the day.
All right, that gives you a little bit of sense of what we mean by democratization of design. Now we'll take Sprout and you'll watch us expand that to beyond just a physical system to a whole room sort of computing, and you'll see some of that coming up here in the near future. But when we transform and look at the back end of this now, how do you take that front end design and now print it out? And that comes our Multijet Fusion. And if you look at 3D printing today, there are essentially 4 big problems. They're slow, quality is low, cost is expensive, and they're not reliable. And so what we've done with Multijet Fusion is go address all of these in an open platform. So now as a little bit of background to give you an idea, let's talk about how 3D printing works. Today, there are essentially 3 technologies. There's material extrusion, there's laser sintering, and the last one is HP Multijet Fusion. And as you see here, the first one, Multijet Fusion, is very simple. It's essentially a glue gun on an XY table that you pump different materials through. You operate one level at a time. You essentially melt a piece of material and trace in a very serial fashion across. Obviously incredibly slow, obviously not very mechanically stable in terms of the fractures are easy to happen at those boundaries. So you can accelerate this and you can get better parts by using laser sintering. Laser sintering does something similar. Lays down a bed of powder, then you use a laser that tracks then in a serial fashion around, and it essentially fuses the material in place. Now you can get much better quality parts, but it's very expensive because you have to, you have a laser and you have to monitor the heat, and it's still working in a very serial fashion. It has to trace across the whole layer. So laser sintering then, after that, you come with Multijet Fusion. In the case of Multijet Fusion, you can totally revolutionize this. So what you do is take a bed of powder, lay it out, then you take our print bar, which can apply reactive agents, 320 million drops a second, do an entire layer at once, and then fuse it, come back in a fusing layer. So rather than working in a serial fashion, it prints an entire layer at a time. The result is 10 times faster, significantly better quality, and we have the ability to do all sorts of parts. So I'll give you an example here with color. We can now add in color at any single drop because we can control agents and where those agents go at any point in the 3D space. So we can fire any individual color. We can do that on a point basis, build it up layer by layer, until we've built an entire part at any color or any gradient that we would like. Now, it won't stop there. We can change all sorts of part properties. You start with a simple agent, and that's a voxel. A voxel is like a 3D pixel for color printing. We obviously can do color, but we can change surface properties. We can make it rough, we can make it smooth. We can change translucency, we can make it solid or transparent. We can change elasticity and strength. And we can change electrical conductivity. We'll be able to print electronics in 3D parts. And we can do advanced materials. Today, we start with all sort of plastics and polymers. We've proven the ability to do ceramics, and in the future, we'll have a variety of metals themselves. So when you put all of this together, you get a sense of what you're able to do. Complete mechanical machines. Let's take a look at what might be possible.
HP's 3D printing technology enables the world to realize the full potential of 3D printing in fully functional parts. HP functional agents could control texture, friction, strength, elasticity, electrical properties, thermal properties, and more. Imagine a single part with stiffness optimized in some areas, elasticity in others, or wear resistance and friction customized where needed. Or imagine printing a complete electromechanical module in a single 3D build without requiring further assembly. The list of future possibilities seems endless.
Now, I think we're a long ways from being able to print, a lizard that interacts. But you should get the idea, and I do think it's very much within our grasp, of being able to print complete mechanical, electrical machines that have various properties associated with them, and you truly can go realize this whole vision of 3D transformation. So when you combine Sprout and future versions of Sprout with Multijet Fusion, we think we're on the cusp of the next industrial revolution. So coming back to that overall technology shift, which is that blending of our physical reality and our digital reality, is we really do believe by focusing on the physical things around us, using the technology that we have, and creating new experiences, there's a whole world of possibility that will be out there for HP. So in closing, I want to come back to a very simple vision, and I think this picture says it all. I think we all remember growing up when everything was possible. When you were that kid and you could strap on that cape, you could put on that mask, and you became the superhero. Well, when we go into HP, this is the way we'll approach it in the future, is a whole world of new possibilities. What can be possible? What can we go create in this new world of blended reality? Thank you very much.